Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.47 and 3.48 from the book Thermodynamics and Engineering Approach by CENGEL, 5th edition. So first I solve problem 3.47. So in problem 3.47, statement is water in a 5 centimeter deep pan is observed to boil at 98 degrees centigrade. It means that saturation temperature or boiling temperature of water is 98 degrees centigrade at 5 centimeter deep pan. A pan is full of water and the depth of the pan is 5 centimeter. So there the temperature is a boiling temperature is 98 degrees centigrade. Now at what temperature will the water in a 40 centimeter deep pan boil? Pan required is find saturation temperature at 40 centimeter deep pan. So an assumption is given to us that both pans are full of water. Both pans are full of water. So here required is to find saturation temperature or boiling temperature at 40 centimeter. This is 40 centimeter, and 5 centimeter is equal to 5 divided by 100, 0.05 meter, and 40 centimeter is equal to 0.4 meter. So we have to find the boiling temperature or saturation temperature at a pan whose depth is 0.4 meter. So first I find the saturation temperature at this saturation pressure at this temperature. Then I find the change in temperature, and from the change of temperature I can easily find the change in pressure, and from the change of pressure I can easily find the pressure, saturation pressure at uh, 0.4 meter deep pan, and then from saturation pressure I will find saturation temperature. So first I find saturation pressure at 98 degrees centigrade. So from the saturated steam table, saturated steam table at temperature of 98 degrees centigrade, find saturation pressure. So if we check this is the temperature. So this temperature here, this temperature is 95 and 100. 98 is not available here. So at 95 the saturation pressure is 84.55 kilopascal, and 100 the saturation pressure is 101.3. So I will interpolate between these two values. So saturation temperature available in table is 95 and 100, and I have to find the value at 98. So saturation temperature and unit is degree centigrade, saturation pressure unit is kilopascal. So at 95 degrees centigrade saturation pressure is 84.55. At 98 this is required, and let's suppose I give this pressure P1 name, and at 100 degrees centigrade saturation pressure is 101.3. So do interpolation. So third value minus first value divided by third value minus second value is equal to third minus first divided by third minus second. 101.3 minus 84.55 divided by 101.3 minus P1. So simplify this and solve for P1. P1 is equal to 94.6 kilopascal. This is saturation pressure at 0.05 meter deep pan. Now we have to find pressure difference. Now we have to find pressure difference between two pans. One pan is 5 centimeter deep and second is 40 centimeter deep. So now we have to find pressure difference between two pans. So formula for this is del phi is equal to rho g del h, change in height. So del phi, change in pressure, is equal to density of water is 1000 kilogram per cubic meter. The value of G is 9.81 meter per square second, and del H is difference of height between two fans. So one is 0.4 meter and other is 0.05 meter. So simplify this, find difference of these two values and multiply by 9.81 and 1000. So the answer will be 3433.5, and kilogram, this is kilogram, meter per square second, this is equal to Newton, and meter cube and meter, the difference of this unit will be meter. So meter and 1 meter will be cancelled, so this will be Newton per square meter, and Newton per square meter is equal to Pascal. So convert this to kilopascal. So divide by 1000 kilopascal. So del phi is equal to 3.4335 kilopascal. Now we can easily find P2, pressure at the deep pan, which is 40 centimeter. So del phi is equal to P2 minus P1, where P1 is pressure of 5 centimeter deep pan, and P2 is equal to pressure of 40 centimeter deep pan, and in deep pan pressure will be more. So P2 is equal to del phi plus P1. So P2 is equal to del phi is 3.4335 kilopascal, and P1 is equal to 94.6 kilopascal. 94.6 kilopascal. Now we have to find, to add these two values, so P2 is equal to 98.03 kilopascal. Now we have to find saturation or boiling temperature at this pressure. So from saturated steam table at pressure is equal to 98.03 kilopascal, we have to find saturation temperature. So 98.03 kilopascal is not available, so we will do interpolation. So pressure in kilopascal and temperature in degree centigrade. So in steam table of pressure, this is pressure in kilopascal, so 75 and 100 kilopascal is available and 98.03 is not available. So at 75 temperature is 91.77 degree centigrade, and in 100 degree centigrade saturation temperature is 99.62. So at 75 kilopascal saturation temperature is 99.77, at 100 kilopascal saturation temperature is 99.62, and we have to find temperature at 98.03 kilopascal. So do interpolation, third minus first divided by third minus second is equal to third value minus first value divided by third value minus second value. So solve this and find saturation temperature, which is 99 degrees centigrade. So it means that boiling temperature or saturation temperature at 40 centimeter deep pan is 99 degrees centigrade. Now we have to solve problem 3-48. So problem 3-48 is statement is a cooking pan whose inner diameter is 20 centimeter is filled with water and covered with a 4 kilogram lid. If the local atmospheric pressure is 101 kilopascal, determine the temperature at which the water start boiling when it is heated. So this is a pan, and pan is covered with a lid. This is lid. The diameter of this is given as 20 centimeter, and mass of this lid is equal to 4 kilogram. Atmospheric pressure is given to us is 101 kilopascal. So we have to find the boiling temperature. So here if we neglect the mass of the lead, then we will find the boiling temperature at this pressure. But as mass and diameter is given to us, so we will include the weight of this lead. So here one is atmospheric pressure, which is given to us, and second pressure is pressure due to weight of the body. Pressure due to weight, P is equal to mg W divided by area, or mg divided by A. So total pressure is equal to PATM plus mg by A. If if mass and D are not given to us, then we can we can assume that the the pressure due to the lead is neglected. So but here mass and die are given, so we can include this value. So P total is equal to P atm plus mg divided by A. So pressure is equal to atmospheric pressure is 101 kilopascal, mass is 4 kilogram mass of the lead, value of G is 9.81 meter per square second, and A is equal to pi by 4 d square. A is equal to pi by 4 d square, and the value of D is 0.20 centimeter, which is equal to 0.2 meter. So 0.2 square meter. And if we calculate this value, the unit, this is kilogram meter per square second. Kilogram meter per square second is equal to Newton, and this is square meter. So Newton per square meter is equal to Pascal, but this pressure is in kilopascal. So if convert this value into kilopascal, so multiply and divide by 1 kilo. So this is kilopascal, and kilo is equal to 1000. So I multiply this value by 1000 and divide by 1000. So this 1000 is equal to kilo. So now this unit will be kilopascal. Now calculate this, which is equal to 101 kilopascal, and if I calculate this value, pi value is 3.14. So this value will be equal to 1.249 kilopascal. So total pressure is equal to 101.249 kilopascal. Now I have to find the boiling temperature at this pressure. So if I add, this is 102. This is 102.249 kilopascal. So now from saturated steam table, from saturated steam table at pressure is equal to 102.249 kilopascal. Find saturation or boiling temperature. So if we check the steam table, so 102.249 value is not available in the table, so we will do interpolation. This is in degree centigrade. Pressure 75 kilopascal and 100 is available. Sorry, 100 and 125. 100 and 125, and we have to find the value at 102.49. Temperature at 100 kilopascal, temperature is this is 100 and this is 125. At 100, 99.62, and at 125 this is 105.99. So this is 99.62, and at 125 105.99, and we have to find saturation temperature at this value. So third minus first divided by third minus second is equal to, this is 105 third minus first divided by third minus second is TS. So 125 minus 100 is equal to 25, and 125, I calculating this value, 125 minus 102.29, 125 minus 102.249 is equal to 22.751. This is equal to 22.751, and 105.99 divided by 99.62 is equal to 6.37 divided by 105.99 minus TS. So this implies that 22.751 multiplied by 6.37, cross multiply 144.92 is equal to 105.99 multiplied by 25 is equal to 2649.75 minus 25 TS, cross multiplication. So this implies that TS is equal to, rearrange this equation, so TS is equal to 2649.75 minus 144.92 divided by 25. This is equal to 100.19 degrees centigrade. This is equal to 100. So the boiling temperature is a 100.19 degrees centigrade, and the problem 3.48 is completed. So for more problems, please like and subscribe my YouTube channel and share with your friend. Thank you.